Hi again. In this video, we're going to talk about finding an ideal sample size. So in the last video, we already kind of saw that there's a relationship. And I mentioned that we had a larger margin of error in the baseball example, and at least partly because of a small sample size. The confidence level, as we've seen, also influences the width of the confidence interval. So that influences the margin of error because that influences the Z star. But the N is also in the formula too, right? So both Z star and N are influencing our confidence interval, okay? So then in our healthcare example, we had a much larger N. We also had a higher confidence interval, so that would make it wider, but we also had a higher N, and we had a smaller margin of error, about 4 versus about 7.6. Okay, so let's look at N in more detail in this video. So sometimes you might know you want a certain margin of error ahead of time before you do a study, okay? It's probably a good thing to know, right? Do you want an estimate within plus or minus 1? Plus or minus 2, plus or minus 5, plus or minus 8. What is the margin of error you're looking for? And if you know that, we can find the sample size N that's needed. So this formula that starts with N equals, it comes from this margin of error that we've seen before. This is the margin of error formula down below. I'll box that as well. The margin of error is equal to the Z star times the square root part of the P hat Q hat over N. That's our margin of error. So if you use algebra, and you're welcome to try this, if you like algebra, try it out. You can solve this equation for N. So N's in the denominator in a square root. So first we'd have to square, well, first I'd move the Z star over to the other side. I'd square both sides. I'd have to multiply both sides by N, and then divide by whatever's remaining, whatever's next to the N. So when you do that, you come up with this formula. N equals P hat times Q hat times the quantity Z squared over the margin of error squared. Okay, ME is one thing. It stands for margin of error. Okay, so, which is great, but we do have to sort of have an estimate for our P hat and Q hat in order to do this. So often we'll use a previous study. What do we think it is around? Otherwise, we just, we need some kind of estimate in order to do this. Okay, another thing that's important is sample size must be a whole number, right? So we can't sample 20.4 people. So we're always going to round up, okay, even if the decimal's under 0.5. So I'll talk more about that when we get to a situation like that. But if we were to round down, we wouldn't get the desired margin of error we want. It would be slightly larger. Okay, so here's an example. An article titled, "Tongue Piercing May Speed Tooth Loss." Researchers say, that's part of the title, they found that 18 out of 52 participants had receding gums, which can lead to tooth loss. Okay, so how many people need to be surveyed in order to estimate the proportion of pierced tongue people with receding gums to within 3% with 95% confidence? Okay, now remember there's a difference between correlation and causation, because there could be other variables involved, right? Confounding variables. Okay, so we've got 18 out of 52. That's our P hat, right? So I'm going to write what we know. P hat is 18 out of 52. That is an old article. So it's like this is where we're taking a previous article and we're doing a new study. So we're going to use that as our initial estimate. So 18 out of 52 is 0.3461 with a 5, so 0.3462. Okay, and then within 3%, that's our margin of error, right? They're saying they haven't written the plus or minus, and sometimes they will, but within also means on both sides, plus or minus 3%. So that's our margin of error, or ME, equals 0.03. And we have to keep everything in decimal form for our calculation. And then 95% confidence, that tells us our Z star, right? Okay, so let me go ahead and write out this formula here. N equals P hat 0.3462 times Q hat, or you can do 1 minus 3.3462 times Z star over the margin of error squared. So Z star is for 95%. I know that one in my head, but I'll bring up the chart here. The other ones I don't know in my head. I have to look up, but I recognize them when I see them because we use them so much. But 95, I know that one in my head is 1.96. 1.96 over the margin of error is 0.03, and then remember to square that fraction in the parentheses. Okay, or maybe I'll write it underneath. We'll see if I have space. Okay, so kind of like when we're doing our margin of error calculation, I want to put this all in my calculator at the same time, or all in Desmos calculator at the same time, because I don't want any intermediate round off error. If I was to divide the Z star by the margin of error, I would get a decimal. And then when I square it, I get another decimal and multiply this decimal. You know, there could be a lot of intermediate round off error, and I don't want that. So I'm going to type it all in, but it's pretty straightforward left to right. You just have to have the parentheses and square at the end. Okay, so let's start. 0.3462 parentheses 1 minus 0.3462. Close parentheses, open parentheses, 1.96 divided by 0.03, close parentheses, square. And my square key is right here. I don't have to do second or anything. Now what's great is in this order of operations, it's really 3 things multiplied and a square. So we don't need any additional, we've got enough parentheses already. We don't need anything more than what we have. Okay, so that came out to be 966.14. Okay, so I'm going to write down the decimal, even though that's not going to be my final answer, because we can't survey 0.14 of a person, right? We can ask their big toe what they think. Or maybe that's their whole foot. I don't know. We can't survey part of a person, but we do need that part of that person. So we need to round up. So we're going to round up to 967. So let me write that out. Round up to 967 people. Okay, if we were to round down, we would end up, and then we calculate our margin of error. So if we went down to 966, calculate our margin of error, it would be bigger than 3%. It would be 3 point something percent. Probably pretty small, but we wouldn't be within 3%. So this is a case where we need the 0.14 of a person, so we're going to round up and survey the entire person. Okay, great. So then I could answer this. We need to survey 967 people to have I'm going to abbreviate because I didn't leave myself quite enough space, an ME, or a margin of error, of plus or minus 3%. Okay, and remember the 3% is optional. It's kind of understood that that's goes with the margin of error, but if it helps you to write that and remember that, that's totally fine. Okay. Great, so that's one example. Now there's a part B on this one. Suppose we decide that a margin of error of 8% would be sufficient. Okay, so that's much larger. Again, with 95% confidence, what's the necessary sample size? Okay, so everything else stays the same unless they specifically tell us what's changing, like this margin of error. Margin of error is now going to be 0.08. Everything else stays the same. 95 confidence staying the same. P hat, Q hat staying the same. So let's go ahead and calculate this. What do you think is going to happen based on what we've talked about already? What do you think is going to happen? Is it going to get bigger, smaller? Okay, actually, let me keep the formula on while I write it out the first time, and then I'll move it up. Okay, so N equals P hat, Q hat. So that's going to stay the same as last time. 0.3462 parentheses 1 minus 0.3462. Okay, then parentheses 1.96. We're keeping the same confidence level. 1.96, but this time we're going to divide by 0.08. And we're still going to square it. Okay, let me move that up now and go ahead and calculate it. The great thing about Desmos is you could just keep everything's typed in there. You could just go and replace that 0.08, right? Replace the 0.03 with 0.08. So that's one nice thing about doing it with a computer app. 0.3462 parentheses 1 minus 0.3462, close those parentheses, and then open parenthesis 1.96 divided by 0.08, close, square, and enter. 135.86. People, right? We're going to always put people when we get to that point, but we can't have 0.86 of a person. In this case, it's greater than half a person, so we would round up anyways, but we're always going to round up. So we're going to round that up to 136 people. Okay, does that make sense to you that it went down? We have a larger margin of error, so we don't need as many people. That fits with our sample-to-sample. Smaller sample sizes have a larger sample-to-sample variation, right? Okay, so to answer this one, we need 136 people in our survey to have a margin of error of 8%. Okay, so write that out in a slightly different way. Okay. Great, let's do another example. And again, if you feel ready to do it on your own, try it out and then come back. Otherwise, we'll keep going together. It's believed that 25% of adults over 50 never graduated high school. We wish to see if the same is true among 25 to 30-year-olds. Okay, so this is another time where we need some kind of p-hat to start out with. And even though it was a different age group, they're trying to see if that's true among this other age group. How many of this younger age group must we survey in order to estimate the proportion of non-grads or non-high school grads to within 6% using 90% confidence? Okay. And then I want to state one additional point on here, that is, if we don't have any idea whatsoever, then we can always use 50-50. Just use 50. That's kind of the worst case scenario. So I'm going to write over here, if unknown, use 0.5 or 0.50. Okay, and then we would put 50-50 right here for our P hat and Q hat. Okay, but we do know we have an estimate of 25%, so let's go ahead and try that. How many of this younger age group? Okay, so let's start our formula, n equals p hat q hat, so 0.25. I like this one because I can do it in my head. 0.25 times 0.75, or you can always do 1 minus 0.25 to get the 0.75. So that's my p hat q hat over z star. Now we have 90% confidence, so I need to find my 90% confidence level, or if you didn't have this handy, you could just go right to Staplet, put in a central area of 0.90, boom, you got it. 1.6449. 1.6449 over our margin of error of 0.06. That's what we want, and don't forget to square it at the end. That's a common mistake, just forgetting to square it. And if you forget to square it, it'll come out way too small, so you'll know, okay? So always be thinking, does this sample size make sense for this margin of error and this level of confidence, okay? Use your number sense. I need to clean my calculator. Okay, there we go. Okay, let's plug this in. 0.25 times 0.75. Parentheses 1.6449 divided by 0.06, close parenthesis, square. Okay, comes out to 140.92. Okay, now it's clear we would round that up either way, but it's going to be 141. Okay. So does it make sense that it's this small? First I was like, whoa. Okay, 6% is pretty small. And 90, let's see, 95, 90 is not as wide as 95. So that would tend to make it smaller, but I think it's the 6%. Might have something to do with the 25% p hat as well. Okay, but always just double check your calculation to make sure. In fact, I can just double check it right now. 0.25 times 0.75, parentheses 1.6449, divided by 0.06 squared. Yep, I'm getting the same answer. Okay, did it twice. We need to survey 141 people to have a 6% margin of error. I can even add the confidence level if I want, margin of error, and 90% confidence. Okay, we're not confident of the 141, that's, remember, our interval. Our interval at the end would be 90% confidence level. Okay, another question. Suppose we want to cut the margin of error to 4%. Okay, let's say we want to be a little more precise. What's the necessary sample size? So lots of practice with this formula. N equals, everything else is going to stay the same unless they tell us otherwise. 0.25 times 0.75. Again, 1.6449. This time we'll divide by 0.04 squared, and I'll underline that 4%. Okay, you think you know what's going to happen, right? Double check that. 0.25 times 0.75, parentheses 1.6449 divided by 0.04, close parenthesis, square. 317, yeah. So over double, right? 317, sorry, 0.07, so 318. Even though it's a 0.7, we're still going to survey 318 people. Okay. need to survey 318 people to have a 4%. So that's still kind of large, 4%, right? 4% margin of error. And 90% confidence. Okay. Great. So I think we've seen this relationship before when we were doing simulation as well, right? But let's write out what's the relationship between the number of people sampled and the margin of error. So keeping everything else the same, because we saw that both the z star and the margin of error affect n, as well as p hat and q hat. But keeping everything else the same, just the sample size, okay? So just the number of people and the margin of error. So we saw, let's look at both of our examples. We saw we had a 3% and we went up to 8%. So when our margin of error increased, the number of people we needed went down, right? And then in our second example, we started with a larger 6% and we went down to 4%. And the sample size went up. So they have this inverse relationship to each other. They're going in the opposite direction. Okay, so we could say a larger sample size will give a smaller margin of error. Okay. So they're opposites. And then I could also kind of say it in reverse. If we need a smaller margin of error, we need to survey more people. Okay, so basically saying the same thing twice, but depending on which one you're looking for or which one you're starting with. Okay, great. Well, I hope that gives you lots of tools to practice your homework with theoretical confidence intervals, and I'll see you in the next video.